Mr. McKinney here, just going over indeterminate form for limits. Indeterminate form is when you either get 0 over 0 or infinity over infinity, and we'll be focusing primarily on 0 over 0 in this video. So the first example we're going to look at is the limit as x approaches 2 of x squared minus 4 over x minus 2. Now anytime we have a limit, the first thing we want to do is just see if we can plug this value in and evaluate the limit from the get-go. In this case, 4 minus 4 over 2 minus 2, 2 squared being 4 on the top, would be 0 over 0. You don't really want to write 0 over 0 because this doesn't make sense anyway, so I shouldn't be writing 0 over 0. And the reason I did this off to the side is because I'm not going to be able to evaluate this limit anyway. You don't want to write equals 0 over 0. You'll lose credit. So we're going to rewrite this as the limit as x approaches 2, x minus 2 and x plus 2 over x minus 2. And now we can cancel out our factors of x minus 2. So this would be the limit as x approaches 2 of x plus 2. Now I can plug in the 2, so this is equal to 4. So this limit is equal to 4. Basically, if I had plugged in 2 at the start, I would have gotten 0 over 0, so it's indeterminate form. And on the graph, this is going to look like a hole or a removable discontinuity. Anytime you have 0 over 0, you're going to have a hole, which is going to give you a removable discontinuity, but you can find the limit or the value of the limit by using the extended or the reduced function, which means you factor it and then cancel things out. That's a bunch of vocab terms. All right, so this one's a cubic instead of a quadratic. For this one, we're going to use, in this case, the difference of cubes. You guys need to know the sum and the difference of cubes formulas. So in this one, I'm going to say this is equal to the limit as x approaches 3. Let me back up a step. Why can't we just plug in 3? Well, 3 minus 3 is 0 on the bottom. 3 cubed is 27. 27 minus 27 is 0 on the top. 0 divided by 0 is indeterminate form. So we need to do some more work. We need to try to simplify this original function or find the extended version of it. So if you have a cubic and you have a sum or a difference, you can use the SOAP formula. Same sign, opposite sign, and then the last sign is always positive. So in this case, it would be x minus 3, and then the opposite sign, so the next sign is going to be a plus, and the last sign is always positive, so that's going to be a plus as well. It's a minus b, and then a squared, ab, b squared. So a, b, and then a squared, ab, b squared. Where in this case, my a is x and b is 3. Again, this is sum or difference of cubes if you don't remember this at all. So this would be x squared, a times b would be 3x, b squared would be 9, over x minus 3. Again, I'll be able to cancel out those x minus 3's. So the limit as x approaches 3 of x squared plus 3x plus 9. Now I can plug in 3, and I'm not going to have to worry about dividing by 0 or having 0 over 0 anymore. So 3 squared plus 3 times 3 plus 9. If I was on the free response portion of the AP exam, I would just box it right here because this is the right answer. 3 squared is 9, 3 times 3 is 9, plus 9 is 27. If it was on the multiple choice portion, that would be the answer that would be on the multiple choice portion. So we need to be able to do both, but on the free response portion, you can stop at this step. All right. We don't have an easy way to factor x to the 5th power. There's not a sum or difference of 5th powers formula that we make you guys memorize. But we did teach you guys a trick called synthetic division a while ago. Again, if you plug in 3, 3 minus 3 is 0, 3 to the 5th minus 243. Again, I've got 0 over 0. I'm allowed to write it off to the side, and that's not a problem, just to kind of think to myself. I do not want to write equals 0 over 0. That is an invalid statement, and you'll lose credit on the AP exam. So the way synthetic division works is you write this out with your 0 placeholders. So I'm going to rewrite this as x to the 5th plus 0x to the 4th plus 0x to the 3rd plus 0x squared plus 0x minus 243. Now that I know how many placeholders I need, I'm going to take the coefficients, mostly zeros, and put them into a little box. So 1, 0, 0, 0, 0, negative 243. Whatever I'm dividing by, I take the number that would make it equal to 0. So instead of negative 3, I'm going to put positive 3 on the outside. First number comes straight down. 1 times 3 is 3. Add them together. 0 plus 3 is 3. And then you always multiply. 3 times 3 is 9. 0 plus 9 is 9. 9 times 3 is 27. 0 plus 27 is 27. 27 times 3 is 81. 0 plus 81 is 81. 81 times 3 is 243. Those cancel out, which is good because that means I don't have a remainder, and I can factor out an x minus 3. So this is my remainder, constant x, x squared, x cubed, and x to the 4th. So I can rewrite this original problem. What I've done by the synthetic division is just shown that I can factor an x minus 3 out of the top. That's what this work over to the side was doing. So now I've got the limit as x approaches 3 of the top would factor as x minus 3 times x to the 4th plus 3x cubed plus 9x squared plus 27x plus 81 over x minus 3. If I plugged in 3 here, I'd still be dividing by 0, so I need to cancel these out and rewrite this as the limit as x approaches 3 of x to the 4th plus 3x cubed plus 9x squared plus 27x plus 81. Now I can plug in 3, so this would be equal to 3 to the 4th plus 3 times 3 cubed, which is 3 to the 4th again, plus 9 times 3 squared, which is 3 to the 4th again, plus 27 times 3, which is 3 to the 4th again, plus 81, which is 3 to the 4th again. So these are all 81. And if I do 81 times 5, I'm going to get 405. So this limit is 405. That's the y value that this function would approach if I graphed it as x approaches 3. Now keep in mind that since it was in indeterminate form, that I would have a hole at the point 3, 405. There would be a hole, which is a removable discontinuity in that graph. Another technique we're going to cover in this video is rationalizing. It touches on a topic that Mr. Jansen's covered in one of his other videos. So if I plugged in 0 right off the bat, 0 plus 1 would be 1. Square root of 1 is 1. 1 minus 1 is 0. And then I've got 0 on the bottom. 0 over 0. Can't work with that. That's indeterminate form. If you see a square root, one way that you can often get rid of it is by multiplying by the conjugate, either on the top or the bottom. So in this case, I'm going to be multiplying by the conjugate of the top. So the square root of x plus 1 over the square root of x plus 1 plus 1. Notice that I didn't write limit out here because this is not a limit. I'm just multiplying by 1. It doesn't look like 1, but this is just 1. All right. Now on the bottom, don't multiply it out. Just leave it as x times that. So limit as x approaches 0. On the bottom, I'm going to have x times this factor, square root of x plus 1 plus 1. And on the top, I'm going to have square root of x plus 1 times square root of x plus 1 is x plus 1. I'm going to have the two middle terms are going to cancel. A negative root x plus 1 and a positive root x plus 1 cancel. And then negative 1 times positive 1 is negative 1. Now on the top, I have x plus 1 minus 1. So I can get rid of those. So I can rewrite this as the limit as x approaches 0 of x over x times the square root of x plus 1 plus 1. Now I can cancel out this x, which is why I don't want to multiply it in there in the first place. So cancel that out. Limit as x approaches 0 of 1 over the square root of x plus 1 plus 1. And now I can plug in 0, because I'm not dividing by 0 anymore. 1 over the square root of 1 plus 1. This was really 0 plus 1. So 1 over 1 plus 1, which is a half. So again, since this was in indeterminate form to begin with, that meant that there was a hole in the graph, a removable discontinuity, and the value where that would be happening is equal to the limit. So at the point 0, 1/2 on this graph, there would have been a hole. But the limit coming from the left and the limit coming from the right would both be equal to a half. All right, fast adding is a way to add fractions together, and you don't have to worry about getting the common denominator. So in order to simplify this fraction, and again, if I plug in 0, I'd have 1/4 minus 1/4, so 0 on the top, 0 on the bottom, indeterminate form. So there's going to be a hole. I need to figure out where that hole is, and that'll tell me what the limit is. So fast adding is just a way to add two fractions together. And the way you do it is you basically just say, okay, I'm going to just make the common denominator have this and this in it. So I'm going to keep, whoops, I need my limit out front. So the limit as x approaches 0. And I'm still just got this x on the bottom. On the top, I'm going to have 4 plus x, and I'm going to multiply the top and the bottom here by 4. Minus, and on the second one, it's already got the 4, so I'm going to multiply by 4 plus x. So minus, parentheses, 4 plus x over 4 times 4 plus x. Now I can combine on the top, because I have a similar denominator in the numerator of my whole fraction. I'm going to distribute this negative, so I'd have 4 minus x over 4 plus x times 4 over x. I already messed up. I forgot my limit statement, so I need to make sure I put that in. You need to keep writing the limit statement until you actually plug in the value of 0, or the value of x that it's approaching. In this case, I can't plug it in because I would still have 0 on the bottom, and if I worked out the top, I would still have 0 there too. So what I can do is do 4 minus 4 and start simplifying a little bit. So I'm going to get the limit as x approaches 0 of negative x over 4 times 4 plus x over x. Now there's a lot of different ways to visualize this, but I can cancel out this x and this x. You can either think about the definition of dividing fractions, so multiplying by the reciprocal, or you can just think I'm going to multiply the top and the bottom by 1 over x. So those will cancel out. Those will also cancel out. So it would be the limit as x approaches 0 of negative 1 over 4 times 4 plus x. If I plug in 0 on the bottom, I'm not dividing by 0 anymore. So I can plug in 0, negative 1 over 4 times 4 plus 0, 4 times 4, this whole thing is negative 1/16. All right, so that's it for a quick summary of some topics you guys learned before calculus and how to apply them with limits when you have indeterminate form. Hope it helped.